In this video, we're going to do an example of a potential difference problem. In this case, a positive 2.0 microcoulomb charge is initially 0.20 meters away from a fixed minus 5 microcoulomb charge and is then moved to a position 0.5 meters from the fixed charge. Part A asks what is the change in potential energy of the two charges, and B asks would it take positive work or negative work to move the charge. Okay, let me sketch this out. Because there is a fixed charge, I'm going to draw that first. And I'm calling it -5 times 10 to the -6 coulombs. Remember, microcoulombs means 10 to the -6. So there's my fixed negative charge. I'm just putting in here a number line, like just basically a line to show the distance away. I'm now going to draw in my positive charge. It is initially 0.2 meters away from the fixed charge. It's going to get moved further away, and it is now a distance of 0.5 meters away from the fixed charge. I'm using initial and final notation here for the distances away, and we'd like to know what is the change in potential energy of these two charges. So because we have a fixed point charge here, the capital Q, I'm going to find the potential at different locations due to that charge. The general formula for a point charge is K, and we're going to use Q here, over R, where R is the distance away from it. At the initial location, R is 0.2 meters. V naught is going to be KQ over R naught. So remember, K is a constant. It's 9 times 10 to the 9th. Newtons per meter squared, coulomb squared. So I'll use that in my equation. And if I plug in the value for Q and for K and for R naught, we get minus 225,000 volts. Very large number. If I do it for the final position of 0.5 meters and plug everything in, I get negative 90,000 volts. So the potential difference between the initial and final, V final minus V initial, is going to be minus 90,000 volts minus negative 225,000 volts for an overall difference of positive 135,000 volts. So that's the change in potential from a position of 0.2 meters away from the fixed negative charge moved over to 0.5 meters. So how do we find the energy? Well, the change in energy for a charge put in is Q times that delta V. So the charge is positive, so we're going to get positive 2 times 10 to the -6 coulombs times positive 135,000 volts. You get an overall change in potential energy of 0.27 joules. So energy had to be added in order to move that charge. So that's the answer for part A. Now for part B, you can see here that since the change in potential energy was greater than 0, energy needed to be added in order to move the charge. In other words, in order to move the charge further away from the negative charge, we would have to actually put energy in and physically pull on that positive charge to move it away, because to overcome the attraction to the negative charge. So since we change its potential energy and it gets moved further away, it's going to take positive work. And if you think back to our unit on energy, that means that if we're moving it to the right, in order to get positive work, we'd have to apply a force in that same direction to it. And you can see that we would have to apply that force to move the positive charge further away from the negative charge and to overcome that attraction. So it's going to be positive work needing to be done. All right, if you have any questions on this problem, please feel free to contact me about it. Other than that, thanks for watching. Have a great day.